look at product rule of differentiation. If a function, for example, if a function like this is given, y equal to uv, you have that your dy dx will be, keep this face, differentiate this, you have your u, differentiating v, you have the v plus all over what, dx, plus you keep this function face v, and differentiate this so that you have your du all over what, dx. This is just what, a product rule on what, differentiation. That is telling you that there are some functions that will be paired together, and how you could differentiate them is using what, product rule. That is two functions multiplied together. Let's see an example. Will explain more. For example, we have one. If I have this function y equal to 4x minus 2 into what, 3x squared plus what, 1. If I have a function like this, I write my solution. Please look at this function. It is a multiple function. It is under what, multiplication. So what you have to do, the first one is your what, u, and the second one is your what, v. So I can say that my u is what, 4x minus 2, and my v is what, 3x squared plus 1. So that my du all over what, dx will be what, 4. Look at this. Remember, I taught you how to differentiate a function times and what, take. This is the only place you are having the function of x. When you differentiate a constant, it is what, 0. So the power here is what, 1. And if you multiply 1 times 4, you will have what, 4. If you subtract 1, let's say we have this 1 minus 1. 1 minus 1 is what, 0. And in this, anything raised to the power of 0 is what, 1. So this automatically is 1. So that we have that my dy, du dx is what, 4. And I can also have that my dv all over what, dx is, the power here is 2. So multiply with the coefficient, I have what, 6x into what, 2 minus 1. And 2 minus 1 is what, 2. So that my answer will be what, 6x. Having u, having v, having du dx, having du, dv dx, and du dx, substitute all of them into this formula so that I have that my dy, this function that was given to me, that my dy all over what, dx of this function will now be u dv dx plus what, v du dx. I have to substitute all the values that I have into this so that my dy of dx is what? What is my u? 4x minus 2. My dv dx is what? 6x. So I multiply the what? 6x. Plus, what is my v? 3x squared plus what? 1. And what is my du? 4. So I multiply with 4. So let's pick this and multiply out here. Let's pick this and multiply out here so that I have, so that what we have was dy dx equal to what? 6x into what? 4x minus 2 plus what? 4 into what? 3x squared plus 1. I hope you can see very well. I'm just, from here, this is what we have. So let's multiply out the bracket so that my dy over what? Dx will be what? 6 times this is what? 24x squared. This times this. That will give you this. So this time this will be what? Minus 12x plus this time this is what? Plus what? 12x squared. And this time this is what? Plus 4. We have x squared, we have x here, so we collect the common factors. This plus this will be what? Sorry, the x will be what? 24x squared plus 12x squared will be what? 36x squared. There is no x here, so we have minus 12x plus 4. And this is our final answer. And there is another rule that we have called. Okay, let's look at another example on product rule. But if you observe, this particular function contains a trigonometry function. So that will take us to what? How to differentiate a tree function. Please take note. Okay, please take note of this before we solve this. Take note, very important. When solving a trig function, when you have that your y is what? Sine x, the y prime will be what? The y prime will be what? Cos x. That is when you differentiate a sine function, you have what? Cos function. And when you differentiate a cos function, you have what? Minus sine x. And when you differentiate what? Tan x, you have what? That your y prime will be what? Sec square x. Please, these are the important, these three things is very important for you to always remember. When you're differentiating a trig function, when you're differentiating sine x, you have what? Cos x. If you're differentiating cos x, you have what? Minus sine x. And when you're differentiating tan x, you have what? Sec square x. So from this, let's see how we can solve this number 2 question. Say that if my y is what? X squared sine what? X. Under what? Under the product rule. So I said that my solution is, I said pick your y, your u to be what? X squared. Your u is always the first, and your v to be what? Sine x. So that my du, so that my du, the x will be what from here? Remember, you multiply this with the coefficient so that I have what? 2x. When you subtract 1, only 1 is remaining. And that my dv over what? The x is what? When you differentiate a sine function, you have what? A cos function. So that my dv the x is what? Cos x. Now substitute that into the general formula that our dy dx, recall, is what? U dv dx plus what? V du dx. You can see it in some cases they will write u v prime plus what? Vu prime. Remember I told you that the u dx is the same thing like saying u prime. So let's substitute what the values we have into this general formula so that our dy dx will be what? What is my u? X squared. And what is my dv dx? Cos x. Plus, what is my v? Sine x. And what is my du dx? 2x. So that I will have that my dy dx is what? X squared cos x plus what? 2x sine x. And that is the answer for this particular function.